Section 7.3, Rational Exponents. Our essential question is, how do you rewrite an expression with a rational exponent? We have 4 new vocabulary words today. The first one is rational exponent. A rational exponent, you can probably guess from that vocab word, is an exponent that is a rational number. Now, there are a lot of rational numbers that we've learned about. The ones that we're going to focus on here are the ones that are written as a fraction, because the first part of the word rational is ratio. So we are looking for exponents that are fractions, and they're fractions where they have integers in the numerator and denominator, and the denominator cannot be 0. Now, the first of those is the square root. We've worked with square roots before, and we know that, say, the square root of 16 equals 4, and technically it's 4 or negative 4, because 4 times 4 is 16, and negative 4 times negative 4 is 16. We're only going to work with the principal square root, though, in this chapter, so we're not going to deal with the negative root. We're just going to go with the positive root, or the principal square root. Now, as a fractional exponent, a square root, so the square root of any number x can be written as x to the power of 1/2. X to the power of 1/2. I'm going to show you why that makes sense. If I square, we know that the inverse of the square root is squaring each side. So if I square the side that has the square root of x on it, the square root and the exponent cancel out, leaving me with just x. If I square the other side, multiplying those exponents together, which we learned about our exponent properties, 1/2 times 2 is just 1. So you can see that they're equivalent. Okay, so now I'm going to get rid of that part. My proof. Okay. The next one is a cube root. A cube root, in the same manner, the cube root of x, so I'm going to put a little 3 here for the cube root. The cube root of x equals x to the 1/3 power, and the nth root, where n can be any number that is greater than 0, the nth root of x equals 1 to the nth power, x to the 1 to the power of 1 over n. So square root of x is x to the 1/2 power, the cube root of x is x to the 1/3 power, and then any other value of n, so that would be 4, 5, 6, 7, 8, and so on, any other positive value, you could write as a power x to the 1 over n power. Okay, now, the directions are going to be changing back and forth throughout the lesson today. The directions here say write each expression in radical form. Radical means that you want to have the root. So radical means we're looking for a root. So when the power, 25 to the 1/2 power, when the fraction on that exponent is 1/2, that's a square root. So I don't need to put a little number up above my little check mark part of that radical symbol. So the square root of 25 we can evaluate, or we can simplify, because it's a perfect square, so that equals 5. The next one, 5x to the 1/2 power, I want you to remember is the same as 5 times x to the 1/2 power. That's really important to recognize, because the 5 is separate from the x to the 1/2 power. So the only part that's going under the square root is the letter x, not the 5. On the third example, with the parentheses, the whole thing is going under the square root. So it's the square root of 19y. So just be careful and notice the difference between the second and third example here based on where the exponent is written, if it's only on the variable or if it's on the entire term. Now, our fractions have changed to 1/3. So 8 to the 1/3 power, since the denominator is 3 in the fraction, it's a cube root. Now the cube root of 8, 8 is a perfect cube. 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2. So remember how a square root is a number times itself. A cube root is a number times itself, multiplied by itself 3 times. So 2 times 2 times 2 is 8. The cube root of 8 is 2. The next one, just like on the last slide, the 15 is not part of the problem that has the exponent on it. So the 15 is not going under the cube root, only the letter y is, like that. And then on the last one, the entire thing is in parentheses, so the entire thing goes under that cube root. And the cube root of 7 isn't a perfect cube. 1 times 1 is 1, times 1 is 1, 2 times 2 times 2 is 8, so 7 is not a perfect cube. If I go back to that last slide, 19, I forgot to point out 19 isn't a perfect square, so you don't simplify that 19 at all. It stays under the root. Okay, now we're going to reverse that process. We're going to take each of these radicals and we're instead writing them with an exponent in exponential form. So these first two, they're square roots. So that means the power would be 1/2. So the first one is 22 to the power of 1/2. The second one is 2x to the power of 1/2. No parentheses here because the 2 was out in front. My third one would be 38 to the power of 1/3. And then my last one, 32w to the power of 1/3. And that's all that we'll do to simplify these for now. That bottom one does actually simplify a little bit further, and we'll work with that later on in this course. Okay, simplifying. So these you should expect to all be able to simplify. Okay, so what that means is if it's a cube root, you should be thinking about a number times itself 3 times here. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 is 9 times another 3 is 27. That's it. So the cube root of 27 is 3. Now the next one's a cube root again, so I'm going to do 4s. 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. The next ones are a little bit trickier. You're probably going to want a calculator to help you out on these because we've got the 4th root of 256, the 4th root. So I'm kind of looking at the size of my numbers here, and I'm thinking if I multiply another 1 here, I'm still going to be at 1. If I multiply another 2, I'm going to be at 16. So this is for my 4th root. If I multiply another 3, I'm at 81. So maybe it's another 4. And it is. So the 4th root of 256 is 4. The 5th root of 32. I'm pretty sure if I multiply 16 by 2, I am going to get to 32. So the 5th root of 32 is 2. So 2 times 2 times 2 times 2 times 2 is 32. Now the bottom one, because it ends in a 5, I'm thinking that I'm going to need the power of 5. So 5 times 5 is 25, times another 5 is 125, times another 5 is 625, times another 5 is 3125. So now I'm up to 1, 2, 3, 4, 5 of them. So a sixth one. Got it. So the sixth root of 15,625 is 5. Those numbers can get pretty large pretty quickly. It's okay if you need to use a calculator to figure these out. Don't worry about that. So all of these simplified so that we got a nice whole number answer. Okay, write each expression in radical form, So we're expecting these to simplify again, just like the last slide. Okay, so the first one has a fraction of 1/2, so it's a square root. The square root of 16 is 4. The next one has a fraction of 1/3, so the cube root of 27, we just saw that. That was 3. 3 times 3 times 3 equaled 27. Like up here, 4 times 4 equaled 16. Another cube root, the cube root of 125, some of you are probably familiar with, is 5. 5 times 5 is 25, times another 5 is 125. And then the fourth root of 256, we just saw that one. That one was 4. 4 times 4 is 16, times another 4 was 64, times a fourth 4 was 256. So those 4 are simplified. If your radical can be simplified, you should simplify it. Just use your calculator if you need help. You should be able to write a summary now. And here are your homework problems. Please make sure to go back to your notes if you're wondering what form to write your answer in, or look in your textbook at the examples in your textbook.